Welcome to today's lecture on industrial oil hydraulics and pneumatics. Today's topic will be hydraulic servo mechanism and servo and proportional control valves. Now, most of the directional control valves act as on off switches, but if the spool of a directional control valve or which is called also DC valve is held at an intermediate position, then it can act also as control valve. Control means in this sense infinite control valve. So, on off, even on off itself is a control which is just 1 or 0, 0 or 1, it is like that. In that case, you will get some intermediate positions to control the flow as well as the pressure. As a result, it acts both as directional control as well as flow control device. However, such a control valve is made with special care and of different geometric configuration for its performance of specific control task. Coupled with the proper position feedback devices and built-in control mechanism, such valves provide very accurate control of position, velocity or acceleration of an actuator. Now, the servo control terms, as you know, that basically means feedback control of position and velocity. So, this are introduction to, you can say, the servo valve. Such a valve is called servo control valve. The mechanical hydraulic servo valve, also called a follow valve, it is called follow valve, was introduced in early stage of fluid power application. Relatively, the electrohydraulic servo valves are modern devices. Now, if we look into this figure, then this is a mechanical servo valve and it is essentially a force amplifier which is used for position control. Now, what we look into this scheme, this is a schematic view, this is a figure of a hydraulic circuit. Now, what we find here, this is a cylinder and this is the high pressure side, this is the low pressure side and here is the load. Okay. Now, this valve we may consider it is an ordinary directional control valve, but this valve can be used as also the servo mechanical valve. How? It is like that we allow, say, by we have given an input. First of all, we have to give an input. Now, if let us consider if it is at the vertical position. Okay. In that vertical position, what will happen? The oil will come to this chamber. This is very schematic. Actually, this may not function if we take just a spool like this, but let us consider it is in the neutral position and then oil from the pump is coming inside, but it cannot go this way or neither it can go other way. Okay. So, in that way there is of course, the drain passage which are not shown. Now, if we give a little movement in the leftward directions, so this will open once this opens, then the oil will go to this portions and this load will move. Now, look at this, here it is written this tank, these small chambers, you can say chambers, but what actually will happen, this valve body, not the spool, valve body will move in this direction, then it will be closed again. So, there will be no motion of the valve, but this input is given, that means this is in a manner the constant input is there. For example, if you use a solenoid, the constant input is there, certain amount of input is there. So, due to this input, again this will open and again this will valve and it will close, and this will go on, and that will occur simultaneously and so smoothly that there will be no discrete motion of this body, not the valve. So, this is basically we should call servo mechanical servo valve, hydromechanical servo valve, and this principle is used in many places, including that copying machines, copying of say lathe, in copying process, this some hydromechanical servo valve is used. Okay. For example, if this is fitted over the template, following this template, it will their feed is through the template and automatically this will move. For a given stroke, to the valve, spool, the piston with load moves along with the valve body coupled to the load platform directly or with an amplifier lever arrangement until the valve comes to neutral. Here it is a direct connection, that means what is the movement of this piston, the movement of this body will be same, but it can be also amplified or reduces. Normally amplification is required, for which this means that suppose this moves 10 millimeter, then this will move only 1 millimeter, because valve movement is very small we need. So, that can be done by a fixed mechanism system or maybe variable system also, the ratio where the ratio can be varied. Further movement of load in same direction causes the reverse flow and thus brings back the load in position. Now, I have shown the motion, but what will happen if it moves further, I mean excess movement, whatever the desired motion, that means whatever the flow rate is given here, it is controlling the velocity. In that case, if it moves further, then other side opens, that means oil is going to the other side, and then what will happen, this will move in the opposite directions. Thus, not only that this position control also will be maintained, that means the velocity, constant velocity will be maintained. Now, this happens together. Now, if there is no sensor, of course, then there is a possibility of drift, that means after some times it may not match. Actually, there will be positioning sensors, and along with that there will be some corrections which is called feedback control to the input side also. However, if you remove this input, then it will be again in this standstill position. Template follower in copying lathe is an example which I have already told you. Hydraulic power steering device is another example. In case of hydraulic power steering, what we do, we give a little movement. Two things we do, one is that we use a very little effort, actual steering force is much higher, and again whatever the steering amount is required, sometimes we have to give more rotations to rotate. Say suppose if you rotate 90 degree, the steering wheel will rotate only 15 degree, it is like that, that ratio is there. So, such magnifications and this following system can be done by hydromechanical servo valve. An electric torque motor, if we consider the electro-hydraulic servo valve, in that case what happens, the electric torque motor or similar device is employed to drive the spool directly, that means single stage, or through another pilot device which is two stage in electro-hydraulic servo valve. Here I would like to mention, in some cases for very large force and very high flow, sometimes the 3-stage valve is used. The pilot stage operates another stage which is called secondary pilot stage, and that pilot stage will ultimately operate the main valve. Now, this is a somewhat schematic view of a single stage servo valve. What we find here, that this is a flapper. Now, this flapper is giving the motion to the spool. This is moving this way or the other way. Now, this is driven by an torque motor. What is torque motor? You will find that armature and the core is like that. This can give only certain amount of movement. Okay. So, first what we do, that we give, suppose we have given a torque like this in this directions, then this valve will okay, this what we find, due to this, what is actually happening, that flow from this side is coming here and it is going to the tank, due to which it is giving the motion apparently in this directions, and then this is being closed and this is being opened, and then the flow from pressure side is going to A of an actuator, and from this side it is going back to the tank. Now, this both are pressure supply and these two are two ends of the actuator, and this is a secondary flow. And what is actually happening there, there are two nozzles. We have studied a little bit about the flapper nozzle also. In that case, what will happen, this due to this flow, there will be differential pressure. Due to this differential pressure, it will always try to keep in a particular position depending on how much torque we have applied here. Okay. And then this is the inside feedback, you can say the feedback spring. This is called feedback spring, and this is which is being controlled by not only this spring, but also this flow here. However, then on the actuator there will be a position feedback or position velocity transducer will be there, sensors will be there, that will again will be fed into this machine, which will make some more corrections to make this valve accurate. But servo valve terms is such that it may not need the feedback from the used point. That means, we may not use a sensor there, it is automatically for a given control. Suppose if we can calculate, say this much input will fulfill the requirements, then we can only give that much input to the system and it will be automatically controlled by this inner feedback system. Now, referring to this figure, this the signal to the drive torque motor or similar unit is transmitted from a simple potentiometer or a controller unit comprising of electrical and or electronic devices. If the high torque is required, then definitely you have to take these electrical units. Otherwise, ordinary electronic device which can generate a small amount of force, that also can be used there. Essentially, there is a servo amplifier to boost the command power, which ultimately controls the valve spool to maintain the position, velocity or acceleration of the actuator driving the load. A transducer feeds the signal to the servo amplifier about the desired output. This already I have discussed. Now, this is a more detailed view of such a single stage servo valve. Here what we find that this spool is actually we could say this is the drive system and this is the feedback system, but this is only one stage is there. Okay. In many cases you will find this much is required for the pilot stage, and then this flow what is going to A and B is connected to the two ends of the another spool valve, which is the actual flow control valve there. Now, as you see, these are so details say where you have to say this is the actually this is the spool and this is the valve body and this is the spring. So, you can say this flapper and spring, this is the flapper and this is the spring, and then this is the armature torque arm, and essentially there always a filter is used. So, flow is going through these filters. Okay. Now, this filter is an additional filter. Apart from there will be another filter which is called high pressure filter. This is connected in the line, the flow from where the flow is coming to this system. Now, if we divide this total function of this valve into discrete manner, then we can develop a block diagram for the operation of such a valve. Now, what it is that control signal source is along with the electrical command is given to the servo amplifier boost signal. So, from there again some error may have there, then it is going to the torque motor, and then mechanical or hydraulical, then we find the servo valve, ports, fluid to actuator, then this is again hydraulic, and then actuator moves at controlled speed to controlled positions. So, mechanical and then load, and load to mechanical or hydraulic again, and from there a position feedback or velocity feedback, these are given back to the servo amplifier, which make the necessary plus minus corrections according to again this electrical input is varied, and then again it is given to the torque motor, and thus we get the desired output. So, this you can say together are torque motor and servo valve. This is available in as a single unit. Okay. Then we think of this control pressure here. Now, separate control pressure source is used. That means, this source is a separate source, not the main source here. Usually, the supply pressure via pressure reducing valve and accumulator is employed for control. Reasons to separate source are: 1. Provides more flexibility, secondly permits separate filtering of the control fluid, and thirdly prevents load pressure fluctuation from affecting the pilot spool response. Now, another thing is required which is called dither. The static frictions, that is stiction, creates a major problem in spool motion control. Now, what actually happens? Both external stiction is there. If you think of anything moving on another surface, then what happens? Even in the rolling, there will be some amount of stictions, particularly in case of sliding friction, there will be stiction. So, that motion is usually called that stick slip motion. Now, in case of this spool movement, there is also stiction. The outside stiction, whatever there, we do not have any control of this valve. We cannot have we can expect a smooth system, but there may have some stiction also, higher stiction in the application end also. But however, what we are talking about, that is the stiction of the spool inside this valve, okay. And that creates a major problem. For keeping the torque motor active with low amplitude alternating motion, dither, low amplitude electrical signals is used. Now, what is actually perhaps happen, what I understand, this dither, using this dither, the motion, suppose we are trying to move a body like this, but we are moving this with small vibrations. So, application of this dithers, that eliminates that the friction. So, a dither along with this electrical system in the torque motor is essential for servo valve. Such actuation eliminates friction and thereby hysteresis in spool motion. Okay. We can say this may not be totally eliminate, but it definitely reduces. Now, we will come to a newer topic which is called proportional control valve. Now, that I have already told you that the mechanical servo valve, hydromechanical servo valve is almost devised when the fluid power was introduced, but the electrical servo valves, electrohydraulic servo valves, that has come later. Now, then servo valve is usually constructed in such a way that feedback control, it is built in inside. That means, for a given input, the output is always controlled, and if there is some error, that will be corrected inside. So, we can get very smooth motion and a desired motion of the device which we are actuating, and we ideally we may not use any transducer at the user end. However, these valves are very expensive, because for that feedback control inside and getting desired output, all the components are made very accurately, and that should be very match part. Now, due to that the valve become very expensive, and many cases, in many applications, such valve are used only for that one time. Say for example, for missile, in case of missile, one servo valve is used only for one applications, then this servo valve itself is destroyed, and these are very expensive. Now, this same servo valve mechanism, when we are using for daily applications, say for example, in machine tools, then when it comes that servo valve is not functioning properly, that means inside feedback system is somehow not functioning properly, then there is only way we have to reject the valve, and we can replace that with a new valve. Now, that becomes very expensive. Alternatingly, there was another methods of control that was developed in later stage, maybe only in 70s or 80s in the last century, that is called proportional control valve. In this proportional valve, the hydraulic part, these are the same as ordinary valve, although slightly accurately made, but not like an servo valve components. Now, here what happens that the valve is designed in such a way for a input, given input, say this is a current input or voltage input to the drive unit, that means motor or solenoids, whatever is there, the output will be proportional, and proportional means in most of the cases linearly proportional. That means 1 volt mean 10 megapascal, 2 volt mean 20 megapascal pressure or maybe flow in that way, 10 liter per minute, 20 liter per minute. Now, inside if you think that there is may not have linearity and it is not there, but as such the input output is concerned, this will be linear. So, this design is not an easy task, but still it is possible. We can give some feedback inside, we can also provide external feedback, we can make the open loop, even if we can make it closed loop within computers, but this proportional valve such mechanism can work like an servo valve, although the finer accuracy may not be that much, or in other words what we can get with the servo valve, if we consider that is 100%, we may get similar output with an proportional valve at least up to the 95%, and in most of the cases that suffice. This means that in case of machine tools sometimes this will work, and many other applications also this will work. Not only that, if you think from the other side where apparently it is felt that servo valve could give the better performance, but the servo valve is very expensive, there we can use an proportional control valve and it will give the better performance than the ordinary valve, although it may not give the what the servo valve can give. Now, this proportional control valve, how it works? In many applications better performance achieved out of the system using ordinary valves as desired. On the other hand, servo valves would be expensive and not cost effective. In many such cases, proportion valves could be a good solution. Usually, proportion valves are driven by proportional solenoids. Sometimes we use the phrase proportional control solenoids. In case of proportional control valves also sometimes we call simply proportional valve. A proportional solenoid differs from an on-off type solenoid. Most of the case what we find that electrically actuated valves, ordinary on-off type valve, these are also, they are also solenoids used, but that is on-off type solenoid. If you give the input, the solenoid will actuate fully and it will operate, say this will on that valve, and if you put off the current, then this will be off. That means the solenoid armature will be fully retracted and it will be off. In case of proportional solenoid, depending on the current, the motion will be proportional, but here this motion may not be linear. We are giving 1 volt, for that first 1 volt you may find that the solenoid is moving say 1 millimeter. Next another volt you will find it has moved further 0.8 millimeter. Next 1 volt, that is 3 volt input, you may find it has moved another 0.7 millimeter. It is like that. That may not be very linear. However, due to that motion, then whatever it is controlling, this is definitely controlling a pilot spool. The pilot spool is being controlled in such a way that ultimate output may be pressure control or may be the flow control, that will be linear to this input. Okay. Do not confuse with that this will be also the linear. Not only that, incorporating a position transducer along with the solenoid push rod, solenoid can be operated to have linearly varied output pressure or flow against linearly varied current and voltage input. This means that we usually in case of proportional valve, there is a feedback control for the armature. That means, it transduces position of the solenoid and then it corrects inside to give the motions. That means, if it is already recorded that for 1 volt 1 millimeter motion. So, for that controlling that part there is a feedback system inside, but it is also possible from the externally it can be controlled. What happens? We can develop a control algorithm as the input output is linear. So, that will give the that will calculate very accurately the what will be the input and output or what are the corrections very fast, although it may not be like a servo valve. So, servo valve response may be better than proportional valve, but it will calculate with not much affecting the system. Say for example, if we use a servo valve for the thickness control of a in a rolling mill where the sheet metal is being manufactured, if you use a servo valve, probably if there is an error, then the defective production, that say different of thickness production may be of 1 meter length at the most, and then by that time it will be corrected. If we use the proportional control valve, probably there will be 3-4 meters of length, that is a little defective, that is thickness is more than desired thickness or less than desired thickness, whatever it might be. So, but that may not affect the total production volume. The hydraulic parts is in such valves are of the precision of accurately manufactured ordinary valves, in contrary to super precision components required for servo valves. Now, most common proportional solenoid valves are the proportion pressure relief valve. This is one. This means that in this case we can control the pressure proportionally to the input. Say total range of the system, say it will be from, we would like to operate from 5 megapascal to 15 megapascal, and our current maybe for that will varying from 2 to 8 volt or microvolt, millivolt, sorry, 2 to 8 millivolt, like that. Now, due to that much of change, we will get this output proportionally. This means that in case of setting the relief valve at a particular pressures, we can vary that depending on the load we are handling, and by that process we can save the energy also, because relieving at a low pressure will be less energy loss. Secondly, proportional flow control valve, and thirdly the proportional direction cum flow control valve. Okay. This means that what is proportional direction control? That is that we are controlling this direction with a controlled flow, that is some proportionate, it is some proportion, not the full. That is why this term proportional. Proportional flow control is okay, but proportional direction control, because direction will be either left or right, up and low. A single valve cannot move in all directions. Anyway, the term is proportional directional cum flow control valve. Now, here is a direct drive proportional control valve. Those are again may be direct type as shown in this figure, and direct type means here this is the proportional solenoid. Okay. So, this is an input to this proportional solenoid, and this is input to the feedback system. No, this is position sensor. This one is the position sensor. So, this is input to the position sensor. This is actually the proportional solenoid, and here as we find that this is the spool, and ultimately it is controlling this one. So, this is acting as a pressure relief valve. What is there? According to the current input, this poppet will be controlled, and then this will allow this orifice will open by a certain amount, and in that way the relief valve control will be there. So, this is a direct type, but this direct type has other problem. As you know, the direct pressure relief valve is not good for controlling, I mean there may have instability, although in proportional control valve it is less than a ordinary valve, but still it will be there. So, where we need more stability and very varied pressuring range or frequent varying pressuring range, in that case we will prefer two stage pilot operated type valve. Now, in that this looks like this is, you can say, sectional view, although it is not the original section, but on a real shape, you can say. Now, here this is the proportional solenoid, and this is the transducer part, or you can say that is feedback part, which controls which gives the feedback, and then further it controls. The control unit is outside, and sometimes also the control unit is inside, or in other words I would say in this case there is a card to drive these two, and in that card there will be some control, position feedback control of this solenoid, that means this spool end. Now, there is a, what we find, there is a main spring, and this spring is to just to position this poppet, and this is the varying orifice which is controlling the orifice size, and by that this pressure control. Now, this is an additional part, this we can keep or may not keep. This is ordinary pressure relief valve for maximum setting. We keep it, suppose this system will work from 5 megapascal to 10 megapascal, then this setting will be at 10 megapascal. So, when if this does not function, then this valve will function, and then relief will be there, or this is for extra safety device. However, we can remove this. So, let us, this is removed, and then what we find that there are orifices. Okay, I shall describe this with a schematic view. If we look into the schematic view where this part is removed, then what we find here, you can compare with this figure. Here we find a orifice. This is we can change this orifice. So, this is as if the external insert is there, but there is a permanent orifice too, and after that there is another orifice, and then this is the variable orifice, and then this orifice is connected to this other end of the main spool, and then this is the leakage flow which is going through an capillary passage and to the chamber. Now, this is the system line, and it is connected here. What happens in normal conditions, suppose this is, we have given an input to control this, say 7 megapascal, the system is working at 5 megapascal at that moment requirements. So, 5 megapascal pressure is coming over here. Now, this flow is going here, 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 it is connected. Now, as this is set with some current to have the 7 megapascal control. So, definitely force is more and this is closed, this is remain closed or very slightly open to give a constant flow through this. As there is a constant flow, there will be a pressure drop in this side, and then due to this differential pressure still it will remain closed. This spring force and differential pressure force, the whatever pressure here, this pressure will be less, but there is a additional spring. So, that spring force plus this pressure force is more than this force. So, it will remain closed. Now, suppose this increases, pressure increases, then what will happen? The more force will be here, orifice size will increase, more flow will be there, more pressure drop will be there, and then this at one point the spring force and this pressure force will be less than the force here, and then this will be lifted, oil will go through this. Now, this is working on the differential pressure, both side there is a force, but one force is other less than the other, and that is why very small control unit. So, therefore, the stability of this spool will be more than the directly valve. Why we need such things? Because when the flow begins, definitely pressure drops here. So, due to this pressure drop, again it will try to close, but due to this differential pressure process, it will not ordinarily close very quickly. So, it will remain in stable condition for longer time. So, this is the basic function of the proportional valve, and we will learn it more in the when we have detailed discussion on the function of proportional valve. Now, an introduction to spools construction. Now, although we should say that we are thinking of the valve constructions, but in this lecture I shall cover only the how the spool is manufactured, how we can maintain such accuracy in case of spool, and that is mostly related to servo valve spool. Now, valve spool, many possible port connection in mid positions are possible with DC valve. DC valve, direction control valve, we can make it on off, and we can make it the infinite position control, and again it might be closed port, open port, fully closed, partially closed, many such things. So, while we are designing such spool, we have to take care of both functional aspect and also material aspects. The common three of them that positions. In the open center valve, all lines are interconnected in mid positions, that we know. Hence, in hydraulic systems flow is permitted back to tank at relatively low pressure, thus eliminating the heat generation associated with closed center valves and constant delivery pumps. In the closed center valve, on the other hand, all lines are closed off in the mid positions. As discussed before, this enables a cylinder to be held at an intermediate position. So, a benefit of being a closed center, that not only the fluid becomes ready, but we can keep the actuator at the current position. There are other reasons for using this type of valve. For instance, if a hydraulic circuit employs an actuator, then a closed center valve will prevent loss of accumulator fluid while the spool move from one extreme to other. The tandem center valve contains the advantage of closed and open center valves. It has the center actuator side center will remain closed, but the pump to tank will remain open in case of tandem valve. That saves the energy as well as keep the workload at current positions, but by that we lose some other advantage of being closed center valve. In this case, although the pump is connected to tank in mid positions, minimizing heat generation, the cylinder ports are blocked, holding the load rigidly in position. Now, valve spool, when accurate control of position is needed, a servo valve is essential. The 2 and 3 position valves discussed earlier find their application in what are essentially open loop systems. In a closed loop systems, the valve must respond not only to input changes, but also to output changes. This is the principle of feedback. Most automatic control systems are proportional to controller input, and experience has shown that such systems can be very accurate. In the controller, if the controller uses fluid power, then the valve must be proportional in its action, and infinite position valves are used. Because of their association with servo systems, these valves are called servo valves, and most of these control power by throttling the flow through variable orifices, and the relevant data are relevant when calculating servo valve performance. In what follows, the valve supply pressure will be assumed constant, the constant pressure system. Some systems use constant flow rather than constant pressure. These are I would say that either we can follow a constant pressure system where the pressure is controlled to a certain limit, and in other cases we can also go for the flow control where flow remain constant for an operating zone. Now, the spools constructions, a little bit about how the spools is constructed. In many cases, a special purpose valve is needed to be an integral part of the component where a ready-made component cannot be used. Moreover, for determining the performance of a system accurately, it is necessary to make a valve of research standard and not of commercial standard. Therefore, it is essential to have some knowledge on the construction, namely material selection, surface preparations and treatment, geometric and tolerances and sealing, etc. Now, fluid property and spool material choice. Normally, spools are made of steel. Now, if the hydraulic oil is petroleum based, then it is relatively non-corrosive and have fairly good lubricating qualities. In this case, steel is the logical material. For valve bodies, normally graded CI and CS are used. That means cast iron, graded cast iron, or we can go for cast steel. However, aluminum, manganese alloy are also used to make it light in airborne applications. For non-petroleum based oil, non-corrosive coating is used on steel, or non-corrosive to that oil material like brass, etc. are used. Now, spool material composition, this is not a detailed compositions, but I will give you some idea. For spool, piston, sleeves or analogous parts, material should be relatively brittle and not ductile. Why ductile? Why not ductile? We can say that there are reasons. This does not mean that it should be weak material. In reality, the material should not be of plastic stage. Two important aspects in that we should consider for the above mentioned requirements. Better finishing by abrasive grinding. So, first thing we should have very good finishings, and for the abrasive grinding brittle material will be better than the very ductile material. Secondly, not impingement of dirt on surface. If it is a ductile, then there is a possibility this particle will be impinged on the surface and that will deteriorate the function of this spool. For high performance valve, abrasive machining technique must be used to help the tolerance and surface finish such as grinding, honing and lapping. The same advantage of easier machinability of brittle materials applies also to some of the newer methods such as ultrasonic machining, spark machining and precision liquid or vapor blasting. Now, non-distorting die or gauge steel properly heat treated is very good for spool. Also, we can use the steel which is used for ball bearing. Hardenable stainless steel is corrosive, corrosion resistive. So, that also can be used. Sintered carbides is used for high temperature applications. Also, we can use relatively high carbon steel say C45, C60 with ceramic coating on it. Nowadays, coating technology has developed so much. So, weak material and then coating may also be used, that may reduce the cost in mass production. Now, what are the required tolerances? First of all, the axial, in case of servo spool valve or relatively accurately manufactured spool for proportional valve, the position of this port on the sleeve and position of these lands on the spool is very important, which will control. One is the axial flow. So, axial flow means this side flow versus displacement is the criteria for axial, selecting the axial tolerances, and there is of course, the radial tolerances, that means how much tolerances will be there, that which is working clearance for smooth spool motion is the criteria to decide the radial clearance. Now, for light oil, these tolerances should be say 1.25 micron at the most. However, we can for heavy viscous oil we can go up to 10 micron. Tolerances of on this plus minus 2.5 micron, where we are using 10 micron clearances. However, it is difficult to bore a valve body with these tolerances. Okay. That means, boring of this sleeve, making this bore is difficult. However, we can make the spool of such tolerances, that is we are grinding externally, it is possible. Okay. But there is another problem, which is that this corner finish. In case of spool we can control somewhat, but in case of internal, there it is very difficult to control such these corners. Now, sharp corners is better for the performance point of view, but sharp corners may create the breakage of the corners and then by that the jamming the spool inside. So, material is selected, material, heat treatment, etc. is selected in such a way that after such machinings the corner, whatever may be their finish, that should not break easily. On the other hand, this we cannot chamfer, say land corner, we machine it, and but this is rounded, given a small rounding of, that can be controlled for spool manufacturing. So, I would say this is only an little idea about the what is servo valve, what is proportional valve, and what care must be taken as manufacturing that there the hydraulic components only. And I have followed the following books for preparing this note. So, and you will find mostly all three books may be consulted for this introductory note, and thank you.